All right, we'll get going here a little bit early. So we left off last class. I just started talking about absolute and comparative advantages. All right, so this was the idea that two people, two countries, two companies, if we think about what they could produce if they use all their resources, one of them is just gonna be better, right? We're gonna be able to produce more of a specific good. So that was having an absolute advantage. If with all my resources, I can produce more than the other person, the other country, the other company, I have an absolute advantage. Comparative advantage was, can I do it at a lower cost, right? Can I produce this good at a lower cost? So we'll start thinking about some real simplistic models and determining who has absolute and comparative advantage. So I think I showed you this last class. And we said, if I'm just thinking about, using all their resources, if the US and Brazil were to produce only large jets or only small jets, like I said, very simplified, basic model. We've got two goods we can produce, and we have two countries trying to produce them. Okay. Well, if we look at who has the absolute advantage in both goods, large and small jets, right? If both countries were using all their resources, the US can produce more large jets, so they have an absolute advantage in large jet production. If we're looking at both countries using all the resources, the United States can produce more small jets. They also have an absolute advantage in small jet production. Right? There's a lot of things that we might have absolute advantages in. Right? You can kind of think about, a lot of our manufacturing jobs aren't in the US anymore. A lot of them are kind of, Southeast Asia, they're kind of going overseas. Well, if the US were to take all of its resources, right, it probably could produce more of a lot of those manufactured goods than a lot of these other countries who are now doing it for us. So why is that occurring? Right? Well, if we think about instead, not just absolute advantage, but comparative advantage, right? If another country can produce something at a much lower cost than us, we might want to start trading with them. We might allow them to produce that good, but we produce something else, and then we'll do some trading, which we'll hopefully get to by the end of the class today. But how do we determine who can produce at a lower cost? Right? So if we think about something like this, and I just want to make sure that I'm not jumping the gun here. Well, I am jumping the gun a little bit. All right, I'll hold off on the comparative advantage discussion a little bit. All right, but that's where we're going, right? We want to figure out who has a comparative advantage. Right? Before we do that, let's just draw out kind of what the production possibilities were for the United States. Because if it uses all its resources, it can produce 30 jets, or if it uses all its resources, it can produce 40, but it can't do it at the same time. So maybe I can do some combination of 20 small jets and 15 large, right? There's all these different combinations of production, right? So what is that going to look like, right? Well, if I'm using all of my resources, not the US, basically we can think about it this way, right? So we'll put large jets. I don't remember if this matches up with the slide, but it doesn't matter. We can kind of see we do it either way, right? So I put the two goods that could be produced on my X and Y axis. If the US is only producing small jets, I think I have 40 up there, right? They can produce 40. If they use all their resources, produce large jets, they can only produce 30, right? So it's almost like 40 small jets, 0 large jets, or 30 large jets, but 0 small jets. So you can imagine I can start to have different combinations, like I said before, 20 small, 15 large. So what those possibilities are going to be, basically if you were to draw a straight line between those 2 points that you grabbed out. What that line would tell you is that any of these combinations are possible given what I know about what I can produce of each good. I use all my resources. So as I start to produce more large jets, notice I start to produce a little bit fewer small jets, right? I'm sacrificing some small jet production to get more larger jets. So this line, we'll call that a production possibilities curve or frontier. Kind of both terms are kind of interchangeable. Here it's not a curve, it's a straight line, but it is the production possibilities frontier, which is I can produce any combination of large and small jets on this line. That making sense so far? I think I'm going to jump the gun, so it might go a little bit out of order in the slide, but that's okay. So this line would represent combinations of small and large jet production where I'm using all my resources. Right? So as I'm kind of sacrificing a little bit of small jets, I use all my resources that I kind of saved on, right? Because I'm no longer using them to produce small jets. And I use those resources to produce a few large jets, right? And I give up a little bit more, I use those resources, right? So this line, I'm using all of my resources still. If I were to choose a point below this line, what that's really saying is, think about it this way. If I try to choose a point right here below the line, well, I'm producing 0 large jets, but something less than 40 small. So let's just say it was even 38. Well, I know that I'm not using all my resources, right? I've chosen a combination of goods, 0 and 38, that is below, that line, below using all of my resources. So that same thing would apply to any point within here as well. It's just a little bit easier to see if you just kind of use the axes, because, well, if I had 0 large jets before, I have 0 now, but I'm producing 38 instead of 40. Well, I'm not using all my resources, given what we've been told. So any point underneath that curve, that production possibilities frontier, that's a point where we're not using all of our resources. Right? So why would we not kind of, if we were currently here, we go all the way up here, we go all the way over here to this point in the line. Or there's a bunch of different combinations where we're now using all our resources, producing the highest amount of total units of these goods if we can get out to that line. But you can also imagine, what about points past this frontier? Well, the easiest way to, again, think about it on the axis, right? I know that if I'm using all my resources, I can produce 30 large jets. So points like out here, well, I'd love to be out there, right? Because I'm producing more large jets. The problem is I don't have resources to produce more large jets, right? This point is a desired point, but it's not feasible. I don't have the resources to get there. So same would be true about any point above that frontier. They're all desirable, right? If I was currently here, I get more small jets and large jets if I'm way out here, but it's past the point where I have enough resources to get there. So we're not utilizing all our resources at any point underneath this frontier. We're utilizing all of our resources when we're on the line. We wish we could get past the line, but all the points past it aren't feasible. Right? We don't have enough resources to get there. So that's the general idea of kind of production possibilities, curves or frontiers. And we can do that for every state, right? I just did that for the US. I can also do it for Brazil, right? So I think what I've got, I've got both of them up here. Right? And it's the same process, except for with Brazil, I think actually here I flipped the Y and X axis. Like I said, it doesn't really matter, right? So I think here I put small jets on the X axis and large jet production on the Y axis. So the US, we had 30 large jets or 40 small. For Brazil, 10 large jets or 30 small. You can kind of see each country would have their own production possibilities curve. So something else is hidden in this graph, right? That's going to allow us to start thinking about comparative advantage. Okay? We'll try to do it for the US first, and we'll try to think about both. So I'll match up with what we have on the slides just to make it a little bit easier here. So I said, well, let's just think about the US. Let's put small jets on the x-axis now, and large jets on the y, just so we can match up with what's up here, right? So we had in the US, using all their resources, they could produce 30 large jets or 40 small jets. So the cost of a small jet, we're thinking about it that way, is kind of related to what we said last class. Anytime I do something, there's an opportunity cost, right? So if I want to produce more small jets, the cost is how many large jets I'm going to have to stop producing, right? Because if I'm currently at this point where it's 30 large jets and 0 small jets, in order to get any small jets, I have to start giving up some resources away from large jet production. Okay? So the slope of this line is going to tell me what the cost of my x-axis goods. So think about it this way. If I want to get my first small jet, how many jets am I going to have, large jets am I going to give up production? Right? Well, the slope of this line, right, tells me rise over run. So to get one more unit, how much is the rise going to have to fall, right? So the slope of this line is basically going to be, I'm going from this point to this point, my y is going to go from 30 to 0, and my x is going to go, right, from 0 to 40, right? So the slope of my line here, negative 30 over 40, or negative 3/4. Everybody with me on kind of what I've got going there. Just rise over run, finding the slope of the line. So what that negative 3/4 tells me is that for every one small jet I want, I have to give up 3/4 of a large jet, right? Because I did this for 1 unit. So for every one small jet that I want, I'm going to have to give up whatever the slope is, right? 3/4 of the y jet, of the large jets. So the slope of this line, I think about, tells you the price of your y-axis good. Sorry, the price of your x-axis good, right? The good that's here on the x-axis that we're moving 1 unit over. So I can do that for one country. Well, I can do it for Brazil as well. All right, theirs goes 10 to 30. So if we want to find the slope there, the rise is changing 10 minus 0, right? It's going from 10 to 0. And then the other direction, we're going from 0 to 30, right? So instead for Brazil, we would have what? 10 minus 0 over 0 minus 30, or negative 10/30ths, or negative 1/3, right? And remember, it's for the x-axis good. So we're giving up 1/3 of a large jet to get one more small jet, right? One more of that x-axis good. So who, right? Thinking about comparative advantages, who has the lowest cost to produce that good? Would we say that Brazil or the United States has a comparative advantage in small jet production? Who has the lower cost? Yeah, Brazil only has to give up 1/3 of a large jet. The US has to give up 3/4, right? So we would say that who has the lower cost here? Brazil for small jet production, right? So they would have the comparative advantage, right? Brazil would have the comparative advantage in small jet production because the cost, how many large jets they have to give up, is much smaller. Now it ends up being true. I might have to need a break here. So we just said that Brazil has a comparative advantage. So write this down. Brazil, comparative advantage in small jet production, right? They have a much lower cost. So if you kind of remember Brazil, their cost is 1/3, and US, their cost is 3/4. Okay? So we can also do this the other way. I said the slope of this line tells you the cost of the x-axis good. So if I just flip everything on its head, and I just flip my x and y axis, and I now put large jets on the x-axis, and I put small jets up here on the y. So just flip it. Right? Because now the US, when I plot out, those maximum values of the two goods that they could produce, draw my line between them. Now the slope of this line tells me the cost of a large jet. So now I could go through. I could do this for Brazil as well. Actually, I thought this is 30 in time. Not drawn to scale, but so we've got Brazil and the US, right? If I can get these slopes and I can understand the cost to each country for a large jet, I can figure out who has comparative advantage in large jet production. So what would be the slope of this line? Once again, we're going from 40 to 0, and then 0 to 30. So I think about the fall and rise. So 40 minus 0 divided by 0 minus, divided by 0 minus 30. So we get what? Negative 4/3 if we simplify this. Or the cost of our x-axis good, one large jet, would mean that we have to give up 4/3 of a small jet. Right? Any questions on that?
So how does an improper fraction correlate in the real world? Like, is it just like a net positive if it's negative 4 terms?
So the only reason it's negative, right? You can almost ignore the negative sign if you really want to, right? The negative is just telling you that to get one more of your x-axis good, you have to give up 4/3, right? That's why it's negative, because it's always that you're kind of thinking about starting from one of the extreme points. So the slope is going to tell you that if you want one more that x-axis good, you're going to have to lose, right? It's going to cost you 4/3 of a small jet, right? So the negative sign is always going to be there because we're going to have a downward sloping line, because there is a trade-off between producing this good and that good. I can't, unless, when I'm starting up at this point, I'm using all my resources, right? So unless I'm starting at a point where I'm not using all my resources, there's no way that I'm not going to have a downward sloping line there. Is that?
Yeah, I was more so asking what it means to have the large number on top as it relates to the real.
Okay, so it's not don't think of it as like a proportion, right? It's telling you what the cost is, right? So if this was instead -2, that would tell you that for every one large jet you want, you have to give up producing 2 small jets, right? So it end up being a fraction here, but we could end up seeing integer values, and I think the integers are probably a little bit, we can think about them a little bit easier.
So in that case, the cost is like a whole jet made and
a third.
Okay.
Right? The resources it would take to produce a jet, and if we only had enough resources to produce a third of the jet, right? Any other questions? So I can do the slope here in a similar way. It's kind of easier to see here, going from 30 to 10. So I've got going to end up with a -3, right? 30 minus 0 divided by 0 minus 10. So I'm going to end up with a pretty steep slope. Yeah. Oh, sorry.
So, despite that it's inverted, Brazil still has to be.
So let's look at this, right? So remember these, you can ignore the negative signs if you want to, or just think about, I'm looking for the largest absolute, like the absolute value, right? So ignoring the negative sign. So if we think about who has the comparative advantage in our new x-axis good, right? Because we already figured out the other ones. Well, now we look at the US's cost is 4/3 of a small jet, while Brazil's would be 3 small jets. So their cost is way larger. The person who has a comparative advantage would be that the US now has a comparative advantage because their cost is much smaller when they're looking at large jet production. Right? So I get what you're saying, right? It's a larger negative value, but it's negative because it's reflecting cost. So we're looking for who has the smallest cost. So we actually want to choose the person that has the cost closest to 0. That's what we did in the other one, right? Brazil was 1/3 versus 3/4. Does that make sense? And we want to write these down again. Brazil's cost was 3, US's was 4/3. And you can kind of see the costs are actually just inverses of the cost of the other good. It's always going to work out to be that way. Notice the cost of a small jet was 1/3 of a large jet. The cost of a large jet is 3 small jets. It's always going to be kind of inverse. But you can also walk through it for each one and kind of determine that as well. If you get to this point and you're understanding this idea and you're understanding this process, once you find who has a comparative advantage in one good, because the prices are always going to be the inverse 1 over these prices, right? 1/3 is 3, 1/3 is 4/3. It's always going to be that you only have a comparative advantage in one good, right? When you look at those prices or the cost being inverse, it's always going to result in each country has a comparative advantage in one good. Right? So notice here, Brazil, comparative advantage in small jet production, US have the comparative advantage in large jet production. So it should always be that way. And we can only have a comparative advantage in one of these goods. And we have a simplified model with just 2 goods. Right? We start adding more goods in, things get a little more complicated than what we want to tackle with this class. But this is the general idea. Any other questions? All right. So, we'll see what things I did mention. We got that. I just like this meme. I thought I'd reference something from last class. So the idea of positive versus normative economics, where positive is making statements and the normative is that, you're being kind of saying what should be, right? Normative economics, well, that's just like your opinion, man. You guys haven't seen The Big Lebowski, you're doing yourself a disservice in society as well. So go out and watch it, it's hilarious. So a little bit more complicated of a production possibilities per example. So there is pretty simple, but we can actually extend it to looking at multiple points. So I'll show you one here. So let's assume that we've got a computer, we can produce computers or wheat, right? This is quite the juxtaposition in terms of these two goods, but computers take 100 labor hours, and to produce 1 ton of wheat, it takes 10 hours of labor. Right? So I think this is a little bit easier to think about the cost of goods in terms of the other good, because here, if I had 100 labor hours, like I as an individual, I could produce how many computers? One. How many tons of wheat could I harvest? Yeah, I've got 100 hours, I could produce 10, right? So you can kind of see there, well, if I want to make I can either do 1 computer or 10 tons of wheat. So the cost there to produce 1 computer is 10 tons of wheat. If I just want to produce that 1 computer, I can't harvest any of those 10 tons of wheat, right? So it maybe makes a little more sense when you're thinking about like an individual level and when you've got this like time thing associated, right? There's a number of labor hours. But as an economy, right, we're going to have multiple people. So we don't just have 100 hours, we've got however many 100 hours times however many people we've got. So if we think instead, let's say that with everybody within our economy or our country, whatever, we can produce with our total labor hours, if that's all we do is produce computers, we can produce 50,000. Well, we want to start thinking about, if I put 50,000 hours of labor into computer production, how many computers would I have? If each computer takes 100 hours, so if I put 50,000 labor hours in, divide that by 100, that's how many computers I'll have, right? So I divide 50,000 by 100. If I use all of my labor hours, all 50,000 labor hours, I can produce 500 computers because each computer costs 100. But my people need to eat. It doesn't matter how great of AI we've got. If we don't have any food, we're not going to last long. So in my economy, I start to say, well, look, I got to produce some wheat. I'm going to start taking my worst programmers, pull them off the, or whatever, creating these computers. And so I can start thinking different combinations, right? If I had 10,000 fewer labor hours directed at computers, and I instead took those labor hours and told those people go harvest some wheat. Well, with 10,000 labor hours, how many tons of wheat can I get? Well, 10,000 divided by 10, right? How many hours it takes to get 1 ton? I get 1,000 tons of wheat, right? And then I give up another 15,000. Well, I take those 15,000 labor hours, put them towards wheat production, and that's how many tons of wheat. I could go through and do all these calculations, right? But it's not just that, there is something floating on behind the scenes that we really weren't capturing there, which is that the reason why I have these different combinations of quantities is likely directly related to whatever resource I have to direct that production. More often than not, that's going to be labor, right? We can think about, obviously, we're going to have some capital in terms of like how much money is thrown at the production, but in general, we're thinking about the trade-off is really taking our labor hours and directing it at producing different goods. Okay? So I would then have this production possibilities curve for all these different combinations of this X and Y good, computers and wheat being my X and Y goods. I could graph, throw this on a graph just like we did before. Right? It might make a little more sense putting it in the context of having these labor hours to kind of divvy up. Okay? Any questions? I just try this is just trying to give like a little more of a glimpse into kind of like why we have something like that. Really, there's labor hours floating on around behind the scenes, but we just typically don't see them. What do I want to get at here? Eating computers. Oh, so you think about this production. just to kind of review, see if people are kind of along with me here. I already forgot what the numbers were, so I should probably take this from here. So it was what, 50,000 computers, 0 week. So we can do the exact same thing we just did. So we've got keep week down here. So it was 5,000. If we were producing computers, we have 500. Right? So all I'm doing there is graphing my two most extreme points. The point where I'm producing 0 wheat and only computers, and then only wheat, no computers. Draw a line in between, that's my production possibilities. Okay? So if I want to figure out what's my opportunity cost of one more ton of wheat, remember, to get the cost of the x-axis good, I just need to find my slope. So I'm going from 500 to 0. And I'm going from this point to this point, right? So I'm getting my slope. And then I'm going from 0 to 5,000. I work the math out here. This ends up being what? 500 over 5,000, so negative 110. So for each additional ton of wheat I have to give up 1/10 of a unit of computer production. That's my cost of that x-axis good. I also said we could flip everything, put computers on the y-axis, go through the whole thing again to get the cost of a computer. But remember I said, so if we got the opportunity cost we just found for wheat was 1/10 of a computer. If I instead wanted the opportunity cost, I'm going to abbreviate with PC here, computer, it should be the inverse of whatever the other goods cost. So it should be 1 over 1/10, right? Which would be 10 tons of wheat, right? The cost of one computer would be 1 over the cost of the other good. So 1 over 1/10 ends up being 10. So I didn't have to like flip the whole thing on its head. Once I had one of them, I knew the other good was going to be the same cost except for the inverse, 1 over cost of the other good. Any questions on what I did there? We didn't go through it as the math on the other one. So get the opportunity cost of the other good. Once you find the cost of whatever x-axis good you plotted, to get the cost of the y-axis good, you can just do 1 over this, right? Or the inverse of the slope. All right, so that's basically, I think I have the synopsis of that on this slide. Right, here's kind of us, if we wanted to draw. So anytime I do stuff on the board, I would suggest writing it down. There's probably a reason why I'm kind of drawing these out for you. Anything like most of the questions in this class, especially after like this first week or two, you should almost always have like a graph you're drawing. Right? Usually, like that's how we're going to understand a lot of this. So we don't get as bogged down by the math, and having this ability to draw up these graphs will help us a lot. Okay, so we're not going to use clickers today. As I said, I'm not going to use it until Monday. But I wanted to give you some examples of questions that I might ask. Check the time. Okay. So we've walked through kind of all of this. I might then ask you, if the economy is producing, so let's say we have two different goods here. Age-old economics example, instead of computers and wheat and large and small jets, they use guns and butter. Those are always kind of the two goods that you use. So here on my x-axis, I've got, if they were only producing butter, they can produce 800 tons. If they're only producing guns, looks like they can produce 400 guns. So if the economy is currently at 200 units of butter, how many guns can it produce? Well, if I'm only at 200 units, the amount of guns I can produce using every last resource, would be the point that I'm at on my production possibilities frontier. Remember that line represents me where I'm using all of my resources. So if I'm at 200 tons of butter, I could produce 300 guns. Any questions on that? It's really just kind of following on my graph up to the point where I'd be on that line at whatever quantity I'm being told. Here I'm being told you're currently at 200 tons of butter. So how many guns could you produce? So go up to that point, we're at 300. So usually I'd ask you that question. I give you a minute and a half or so, kind of think about it. This one I might not give it a minute and a half. Hopefully this one wouldn't have been as difficult. And then kind of ask, I'm going to close it out, respond with your answers, and then we kind of go over and talk about it. Usually I'll ask one of you to tell me the answer first. So what would the opportunity cost of 1 unit of butter be here? Well, it's kind of nice, right? Because I'm asking you what's the cost of the x-axis good. So if I wanted the cost of the x-axis good here, what would it be? What represents the cost? Yeah. Yeah, it's the slope of this line, right? How do I get the slope of this line? Well, it's going from 400 to 0, and then from 0 to 800. So 400 over 800, it's the rise over the run. It's falling 400, going up on the x-axis by 800. So 400 over 800 is 1/2. So the cost would be 1/2 of a gun, right? And that kind of makes sense here because we've got two numbers that are easily divisible, right? I can either produce 800 tons of butter or 400 guns. So basically, for every 2 tons of butter, I'm only getting 1 gun, right? So for one, turn that into the price of one thing of butter. So, but probably the easier way to think about it is just find the slope of this line. That tells you the cost of your x-axis good. Okay. What will the opportunity cost be of a gun? Well, this one is one that's a little bit tricky, right? Because I've got this graph for you where butter's on the x-axis. So now I want the opportunity cost of my y-axis good. We just said the cost of my x-axis good butter was 1/2 of a gun. So if I now want the opportunity cost of getting 1 gun, what would I have to do? To change your mind? Yeah.
You would invert 1/2, which becomes 2, so it costs 2.
Yep, it's just 1 over the cost of the other good. We already found the cost of the other good is 1/2 a gun. 1 over 1/2 will be 2, right? So to get the cost of 1 gun, it would be 2 tons of butter. So I just do 1 over the slope there. And that's something that we already talked about. I had shown you an example, and then I would ask you a question. I wouldn't ask you ahead of time, like before you even worked on it. I think that's all I want to say there. So return to this example. I think I changed it because I think at this point, I recalled that I probably was thinking about how I would teach it and started to realize that small and large jets, I was saying jets too much, and I was probably I should differentiate the goods a little bit more before we got into this discussion. So I went and changed it to automobiles. But we've got it's the same numbers that we were dealing with before, it's the same setup. So if we've got costs that vary, right? We found that Brazil had a comparative advantage. I believe it was in small jet production. The US had a comparative advantage in large jet production. It's the same thing here. It's just now US has has jet comparative advantage, and Brazil has automobile, right? Because I've changed the goods here. But it's the same numbers. So, whoops. So if I get that same graph we had before, and we had those opportunity costs, right? So the opportunity cost for an automobile, 1/3 and 3/4, right? That's what we had before. So is there a way that both countries could be better off if we allow them to trade? Right? That's what we're going to try to get at before we leave today. Definitely. So I can draw out, right? We've got both these countries. I could think first about what is my worldwide, right? Or kind of economy-wide. So really there's like a global economy, right? There's each country has their own, and then we have this global economy. So what you might want to do is something like this. Here's my automobiles, here's my jets. So I could take each one of these countries and then say, okay, what's the economy-wide or the global production possibilities frontier? Well, if both of these countries were only producing jets, how many jets would we have worldwide? 30 plus 10, so 40, right? If they were only producing automobiles, how many would we have? 30 plus 40, so we'd be out here at 7. But this is where we now don't simply draw a straight line between those 2 points. Why? Well, remember, that production possibilities curve, or frontier, will tell me the cost of the x-axis good. We know that these two countries have different costs. Right? Who has the lower cost? Compare two numbers for me. Yeah, 0.33 is lower than 0.75, right? Brazil has a lower cost of producing an automobile. So if we're as a world making a decision, who's going to first start producing, between, these are our only two countries, who's going to first start producing automobiles? It's going to be Brazil. They have the lower cost. So they start producing automobiles, right? At some point, right, Brazil caps out. They're producing 30 automobiles. That's as many as they can produce, right? That's what we've got there. So for our worldwide economy, once we run out, Brazil's used all its resources to only produce automobiles, which at that point, this is kind of a caveat, how many jets would we have worldwide if we got to that point where Brazil was using all its resources on automobiles?
It's in the US wasn't producing them zero, right?
So for our, right, we started at a point where both Brazil and the US were using all their resources to produce jets. We said we could get 40 total. As Brazil starts to produce more automobiles, they eventually use all their resources on automobiles, which means they have zero jet production, and the only jet production is coming from the US. So if Brazil gets to 30 automobiles, they've sacrificed producing 10 jets, right? And the only person left producing jets is the US, who, if using all their resources, produce 30, right? So there's two different ways of thinking about why we'd be at that. Now, at this point, any number of automobiles for our worldwide economy, past that, who's going to have to start producing automobiles? Well, Brazil used other resources, so now we go to the US, right? They had the next highest cost, right? Well, their cost was higher, so essentially that slope of that line is going to be steeper, right? We're going to allow the first few countries that have the lowest cost to start producing that x-axis good. But once they use all the resources, then we have to go to the next lowest cost country, and the next lowest cost country. Now it's a little bit easy with two countries here. We're only going to have like two different slopes, right? You can imagine if I had every country in the world, I can start to think about, I'm going to have a lot of really tiny segments as I'm going through each country in terms of the ranking they have for the cost of production. But we can understand it. Same principles would apply. We only have two countries. It's a little bit easier to comprehend like that. Questions on anything here? Okay. So we can build these worldwide or these economy-wide, right? Because I'm doing this as countries in the world. You could do this counties in a state, states in the US, right? But eventually, right, if we had enough countries or enough counties or states, we get something that looks like it has a little bit more of a curve to it, right? But the idea is the same. The slope is going to start out kind of flat because the costs, we're using our lowest cost countries first. And then eventually we're going to have to rely, if we want more and more of that good, on countries that are producing at a higher cost. I don't want to waste time on this today before we go. I've kind of already talked about this, right? We talked about, I did it for one country, but the same thing would apply. If we wanted an economy-wide production possibilities curve, any point in here, we said I'm doing what? Not using all my resources. Any point on the frontier or on the curve, I'm using all of my resources. And if I wanted to be at any point out here, I need more resources. Right? I don't have enough. So it's the same kind of thing applies. That's all this slide is kind of saying. And so we'll kind of move off. And here's a clicker question. I kind of at this point we've kind of beaten this to death, but C, not using all my resources. A and B, using all of them. D, I don't have. I wanted to get to the trade today, so I might come back to this next class. So I'll probably put those slides to kind of start off next class, but I do want to try to get this gains and trade before we go to that. So we've got these same values as the other examples we've been using. Now let's think about this. You've got the opportunity cost of jets in terms of cars for both countries, and the opportunity cost of cars in terms of jets for both countries. So I want to try to think about is, could these two countries trade and be better off, right? Because at this point, like, they're constrained to being somewhere on this curve. Right? But let's say both these countries come to each other, and I can't remember the price that they agree on. Let me look at this and I can probably remember. I think I said they agree that they would trade one jet for two cars. Let's see if I got this number right. We'll go back. So let's imagine that what I said was both these countries come together and they say, okay, look, let's agree on a price that for every jet, it's worth two cars if we're trading with each other. Right? So you can kind of imagine for the US, right? If they want one more jet for themselves, they had to give up 4/3 of a car, right? So why, in order to get, if they gave up a jet to Brazil instead, not, they wouldn't get their 4/3 of the car, they'd get the two cars that Brazil said they would give them. So that price is like attractive to the US because if they stop producing a jet, they only get 4/3 of a car if they produce it themselves. But if they keep only producing jets and then trade one of them to Brazil, well, at that terms of trade at 2 cars per jet, they're getting more, right, than they would have by producing it themselves. So they like that. Brazil says, well, before, if I wanted one jet, I had to, I had to give up producing 3 cars, right? So now, right, giving you 2 cars for a jet, that's actually better off for me as well. So that terms of trade would work for both countries, right? It's more attractive for them to trade than to like shift their resources from jet to car production or vice versa. So anytime we look at the opportunity cost of these goods for the two countries, if we choose a terms of trade somewhere in between the two countries' costs, they're both going to be better off. You can think about if I chose 4 cars, right? Well, for the US, it's like, well, yeah, I would give up a jet for 4 cars. I'm getting way more than 4/3 if I get 4. That's awesome for me. But Brazil says, well, if I do it, I would have to give up 3 cars to get a jet. Why am I going to give up 4 to somebody else to get that same one jet? So the terms of trade has to be somewhere in between the two countries' costs, right? Which is what I think I have here, right? And I did this in terms of jets, right? In terms of kind of setting that terms of trade in terms of how many cars a jet is worth. So it has to be somewhere between the two countries' costs of 4/3 and 1/3. I was using the example of 2, right? So let's say we use that example of 2 and think about this one. So I'm going to keep going back and forth between because this is going to be what we can get to. So notice for the US before trade, right? They had different combinations of jet and automobile production. So just as an example, they could have been at 22.5 jets and 10 cars. That was one of the points along their production possibilities frontier. And let's say Brazil was at 5 jets and 15 cars. That was one of the points on their production possibilities frontier. We then allow them to trade at this price of 1 jet is worth 2 automobiles. Okay? So the US says, okay, well, what if I only produce jets? All right? So we go back, if they only produce jets, they can produce 30. So they use all their resources, they produce jets, and then they trade away 5 of those jets. So they're producing 30 jets, they trade away 5 of them. They're left with 25 jets. But for those 5 jets, for each one, they get 2 automobiles. So when they trade away those 5 jets, they now get 10 automobiles. So they're better off than they were before. They have the same number of cars, but they now have more jets after we allow trade. For Brazil, instead, they say, well, we have comparative advantage in car production. I'm only going to produce cars. Brazil could produce 30 cars. So before trade, right, they were at this point of 5 and 15. Now they're producing only cars, 30 cars, but they trade away 10 of them, right? Remember, they traded away 10 cars to the US for 5 jets because each jet was worth 2 cars. So they produce only cars, trade away 10 of them, they're left with 20 cars. For those 10 cars, the US gives them 5 jets. They've got the same number of jets, but more cars than before trade, right? So as long as we can set a terms of trade, they're in between the two costs of the countries, they can actually both end up being better off after trade than before. Okay? So you don't like free trade. So those are some sweet Nikes you have on, right? So the world operates in that. Yeah, I mean, I think we come at it from a standpoint, probably because we are American and we have flaws, but a little bit egotistical, like the US probably has an absolute advantage in a lot of different things. But there's a lot of countries that have comparative advantages in a lot of things that we don't. And if we allow everyone to specialize in what they produce, and then we allow free trade, everybody can get off, right? Not just these, countries we think of as, oh, well, they don't, they can't produce as much as the US. Well, no. Trading with them can make you better off as well as them. And this is kind of a very simplistic model, but you can complicate the model and add in more countries and more goods, but you end up getting the same result, right? So might as well boil it down to kind of the easiest example to start out. We could add in more countries if we really wanted to, just makes the math a little more difficult. I think, yeah, that was the last one. So we'll talk a little bit more about production possibilities curves, going to wrap that discussion up. And then we'll probably start jumping into some supply and demand stuff next week. I will be using the clickers on Monday, so make sure you've either got it registered on Canvas or you've got it downloaded on your phone. Get registered for Pearson. If there are any issues with that, let me know. The first homework should be available after class today. I think I had it set to, it might not be for another 5 to 10 minutes or so, but it will be kind of opening up here in the next 10 minutes. Okay. No questions for me. All right, you guys have a good weekend. I'll see you on Monday.